Hello, we are Group D from Class 2 Bmma, Section 1, Group 1. Our group title is Steam Cycle and the Reheat Cycle. First of all, I will present the introduction, history, and applications. Steam cycle is known as one of the main power generating cycles, which consists of four key devices, namely a boiler, a steam turbine, a condenser, and a pump. The Rankine cycle is named after William John McConrankine, a Scottish engineer and physicist. Recently, there are many studies focusing on applying Rankine cycle to recover low-grade waste heat on road vehicles, which convert around one-third of the fuel energy into useful mechanical energy for propulsion, are moving energy conversion systems that generate considerable waste heat.
Assalamualaikum warahmatullahi wabarakatuh. My name is Jamal bin Abdul Ghani. I'm going to explain about component of a steam cycle and the reheat cycle. In a steam cycle, steam is the working fluid. There are four main components in a Rankine cycle. These components consist of a pump, boiler, turbine, and condenser. A reheat cycle power system is a heat engine converting thermal energy into work. Similar to the vapor compression heat pump, it comprises four main components: a boiler, a turbine, a condenser, and a pump.
Hello, sir. My name is Rishi. I'm going to explain about the working principles of the cycles. There are two types of cycle, which is steam cycle and reheat cycle. I'm going to explain steam cycle. The fuel is fired into a boiler, which converts the heat released from combustion to steam at a high pressure and temperature. This steam is expanded through a turbine for generation of electrical power. Exhaust steam from the turbine is condensed in a heat exchanger and then returned via the feed pumps to the boiler. Reheat cycle. The moisture carried by the steam at the final stages of the expansion process. In this variation, two turbines work in series. The first accepts vapor from the boiler at a high pressure and reheat cycle. The expansion takes place in two turbines. The steam expands in the high pressure turbine at some intermediate pressure, then passes back to the boiler, where it is reheated at a constant pressure to a temperature that is usually equal to the original superheat temperature.
Okay, so now I'm gonna explain the disadvantage of the steam cycle. So the first one, air pollution from smoke fumes. And the second one is cost more compared to other power station. And the last one is performance, less efficient and less responsive. And next is advantage of the reheat cycle. So the first one is smaller boiler and smaller condenser. And the next one is cost saving, less handling of fuel and firing equipment. And the third one is higher thermal efficiency. And the number 4 is reduce feed water pump power. And the last one is durability, long life of the turbine.
Assalamualaikum and good day, and I'm going to explain about the suggestions to improve the cycle. The first one is decreasing the condenser pressure. So by decreasing the condenser pressure, it will lower the temperature of the steam, which is the heat reduction temperature. The blue area, as you can see on the graph, is the network increases due to the decreasing of the condenser pressure. The second one is superheating the steam to a high temperature. The effect of superheating the steam to a high temperature on the steam cycle efficiency is illustrated on the graph. And the blue area, as you can see on the graph, is the increase of network due to the superheating the steam to a high temperature. Finally, the third one is increasing the boiler pressure. So for a fix in the turbine temperature, the blue area is the network increased, as you can see on the graph, and the gray area is the network decreased. Also, the moisture content of the steam increases from state 4 to state 4 prime, which is an undesirable side effect. This side effect can be corrected by reheating the steam and results in reheat Rankine cycle. That is all from us. Thank you.